Now we move on to basic image processing and analysis, and the first exercise will be cropping a dynamic image and saving that cropped result for use later on. Again, we continue in the View tool. Although unnecessary for loading our new data, we can now clear the workspace and then move to the DB Load tab, where we can select RAT3 from the Bruker PCI database again, and we will load the dynamic whole body PET image once again. We keep the previous layout, which was our 1:8 layout moving through time. In this case, we want to return to the orthogonal planes layout. So we can use the right click in the image display and select the orthogonal layout. We can also restore our slice jump and frame jump to 1 in each case, and set the color table upper threshold to 800. Now what we want to do to analyze this image later is to crop the brain. If we move to the final time frame, then we have the highest accumulation of tracer in the brain. We can even compress the upper threshold of the color table a little further to see the brain with a higher contrast compared to the background in the image. Now we have an automatic workflow to crop the brain. In the lower right of the tool, we have the workflow cropping. Once that has been activated, we should set the species using the shortcut shown here, and in this case select RAT, which will give our crop box appropriate starting dimensions. In fact, then, to crop the brain, we can adjust the dimensions even further. We can keep 34 and 28 millimeter dimensions for X and Y, and then for the Z direction we can reduce that down to 50 millimeters. Then wherever we click in the image, our crop box moves. Therefore, if we click in the center of the brain, we will nicely crop out that brain area for later use. If we were to proceed with the workflow, clicking on the VOIs button in the lower right, we would apply the cropping and move to the next main tab where we could draw VOIs. Alternatively, with the crop icon to the right of the crop checkbox, we can apply the crop here and see the result before doing anything else. Whenever we crop the image, whether with this button or with the workflow, we should confirm that irreversible operation. Of course, we can always reload the data, but within the data we have in memory, this is considered irreversible. So following cropping, we see the reduced image size and our yellow box appears larger. We can then turn off that cropping box, and we need to readjust the image controls. We can move back to the last frame and set our upper threshold of 500, and then we see the cropped image looking more like what we saw before we applied the crop. So this cropped image can be saved back to the database, or it could be saved in another format to be used for something else. We can quickly explore both of those options. To save back to the database, we can use the Save shortcut in the lower right, and we have a whole menu of formats available. If we select Database, then we have a Save Database dialog. We can confirm the database we want to use. If we want to, we can set a certain project or group. You see we already have some projects set for bone, brain, cardiac and oncology data, which represents the data already in this Bruker PCI database. We also have the chance to edit the header information of the image before it's saved. This is particularly useful as we can add something to the series description to explain what was done to the data. In this case, what we could do is follow general format used in PMOD elsewhere and enter that this image has been cropped for the brain. We should accept the lack of series date. It's unnecessary for our SUV calculations and not included in the format from Paravision. And then we can save that data to the database. If we then go back to the DB load page, for RAT3 we now see that as well as the original dynamic PET whole body series, we have the new version just saved, which we added the suffix brain crop to. Alternatively, going back to the View tab, we can also save the image in interfile format. So we can change the save menu once again, select interfile. We get a slightly different image save dialog specifically for interfile. Here we should define the folder to be saved to, save name, and check the transfer syntax and file output. For the folder, we should just, using the browse icon at the end of the line, this opens the general folder and path browser. I can move up a folder, so now I'm in the USB drive pmod trial pmod data, where I have my folder for examples. I can select this folder, I can enter the name RAT3 brain crop, and I should check the transfer syntax. Here we have a difference between syntaxes mainly used for DICOM, the signed word, and, for example, floating point values. Pmod will test the data to make sure that no rounding of the values will occur for a certain syntax, and then we see, as displayed here, that the transfer syntax was validated. If there would be a problem, then a yellow warning would be shown here, and we should change the transfer syntax. If in doubt, use float little endian, as this has the best precision. For interfile, we often have two files, header for the image and the actual image data, so that's fine. Then finally we can save, and if we go to the file browser we can find that image again. For example, through load auto detect, we see the folder that was just used, so we have pmod trial, pmod data examples, and here we have the header and image file that were just saved.